Okay, I wanted to add in this video showing some more examples of Newton's law problems involving free body diagrams. These are very similar to the types of problems that you see in the Forces Part 2 online homework and that you also see in the Forces Review online homework. It would be similar to some of the problems you'll see on tomorrow's quiz. Tennis player strikes a tennis ball with a mass of 55 grams when it is at the top of its toss, accelerating it to 70 meters per second in a distance of 0.020 meters. What is the average force the player exerts on the ball? So let's list out the things that we know. Good steps here. Draw the free body diagram on the ball and list the things that we know. So we know the mass is 55 grams. We have to convert that to kilograms. So 0.055 kilograms. We know the initial velocity of the ball. It's at the highest point of its toss, 0 meters per second. And we know the final velocity of the ball is going to be 70 meters per second. We know the delta x is 0.02 meters. And we're looking for force. Now we know F equals ma. Now the force is going to be the force of the racket. And that's going to be the only force on the ball. So to do F net equals ma, we need to know what a is. We know vi, vf, and delta x. So I'm going to use vf squared equals vi squared plus 2a delta x. So 70 squared equals 0 squared plus 2 times a times 0.02. So 70 squared, 4,900. Equals 2 times 0.02 or 0.04a. The acceleration, very large. Think about it's going from 0 to 70 meters per second in 20 centimeters. So, or 2 centimeters, sorry. 122,500 meters per second squared. Now we can plug this in. F net equals ma, F net equals 0.055 times 122,500. You get 6,737.5 newtons. Next problem. There are two forces acting on a box of golf balls, F1 and F2. The mass of the box is 1 kilogram. When a force acts in the same direction, they cause an acceleration of 0.5. When they oppose one another, the box accelerates 0.2 in the direction of F2. So I need two free body diagrams here. I've got FG, FN, and in the first case, F1 and F2 are pointed in the same direction. In the other case, FN, FG, F1 is pointed to the left, F2 is pointed to the right. So I got two directions here. I'm going to make to the right positive. I know F net equals ma. F net is the sum of all the forces. So in this first case, F1 plus F2 equals 1 times 0.5. In the second case, F1 is negative plus F2 equals 1 times 0.2. So F1 plus F2 equals 0.5. Negative F1 plus F2 equals 0.2. Now I need to solve one of these equations for one variable and substitute it into the other. So I'm going to add F1 to both sides. F2 equals 0.2 plus F1. And then plug that in over here. So F1 plus 0.2 plus F1 equals 0.5. So 2F1 plus 0.2 equals 0.5. 2F1 equals 0.3. Subtract F2 from 0.2 from both sides. F1 equals 0.15 newtons. So that gives my answer for F1. Now I need to find F2. So F2 equals 0.2 plus 0.15. So F2 equals 0.35 newtons. So this involved a little bit more complicated algebra with a system of equations, but the setup was based on the free body diagrams. Next problem, a physics professor lifts her 9.5 kilogram briefcase at a constant speed upward. So we know force of gravity and we know force of the lift. We want to know what the magnitude of her force is. To find the force of gravity, we'll use Fg equals mg. So 9.5 times 9.81. We get 93.195 newtons. Now I know F net equals ma, and I'm going to make up positive. So the force of the lift plus negative 93.195 equals the mass, 9.5, and it's going at a constant speed, so A is 0. So the force of the lift minus 93.195 equals 0. So the force is equal to the force of gravity, because it's moving at a constant speed, so 93.195 newtons. Okay, this next problem, an 80 kilogram man sits on a massless cart that is on a horizontal surface. The cart is initially stationary and it can move without friction or air resistance. The man throws a 5 kilogram stone in the positive direction, applying a force so that it has an acceleration of positive 2.5 meters per second squared. What is the man's acceleration during the same throw? So we have the man and we have the stone. We can find the force of the stone. F net equals ma. So F net equals 5 times positive 2.5. F net equals 12.5 newtons. Now, Newton's third law. If the man applies a 12.5 Newton force to the stone, the net force on the man must be 12.5 in the opposite direction. So negative 12.5 newtons. So negative 12.5 newtons equals 80 times A. He would accelerate at negative 0.156 meters per second squared. Next one, two motionless ice skaters face each other and put their palms together. One skater pushes the other away using a constant force for 0.7 seconds. The second skater who is pushed has a mass of 100 kilograms and moves off with a velocity of negative 1 meter per second. First skater has a mass of 50 kilograms. What is her velocity after the push? So we know a couple of things here. We have skater 1, skater 2. The time is going to be 0.70 kilograms. Skater 1 has a mass of 50 kilograms and an initial velocity of 0. For skater 2, the time is 0.70 seconds. Should be seconds here. Mass is 100 kilograms. Initial velocity is 0. Final velocity is negative 1 meter per second. So we need to find the force on person 2. To find that, we need to know the acceleration. So VF equals VI plus AT. Negative 1 equals 0 plus A times 0.7. So the acceleration here is negative 1.43 meters per second squared. So the force, F net equals ma. F net equals 100 times negative 1.43. So the net force, 143 newtons. We know, therefore, that this person, negative 143 newtons here, so this person must have a net force of positive 143 newtons by Newton's third law. So we can do F net equals MA, 143 equals 50 times A, which is 2.86 meters per second squared. Now we can do VF equals VI plus AT. VF equals 0, 2.86 times 0.7. This person will be moving at positive 2 meters per second. So that gives us a number of examples, and if you've been working on the online Part 2 homework, you'll notice these are very similar to many of those problems. Hopefully this will keep you from getting too stuck on those problems and give you a good background as we get ready for tomorrow's quiz.